Hey everyone, geophysicist Stefan Burns here. Breaking news, there has just been another flurry of high magnitude earthquakes, the strongest of which is this magnitude 6.6, which just ruptured a couple hours ago, and it was extremely deep at 315 kilometers or so. This ruptured right in between Fiji and Samoa. So here we have Fiji, here we have the island of Samoa. Right at the tail end of this subduction zone, we got that to pop off. And this is the latest in a sequence of earthquakes across the Pacific plate. So clearly the Pacific plate has been moving. We also, just about an hour before that, we had a aftershock at Kamchatka, magnitude 6.1. We can see the epicenter of that right there. And that was at 22:37 Universal Time. And what's interesting about this aftershock is that the other earthquakes have been migrating to the south-southwest. So we had this 7.4 on the 20th, then we had the three 6.6s, we had this 6.3 just a couple days ago, and now the 6.1 has gone the other direction as the earthquake swarm that went this way. Of course, that's not just these magnitude 6 aftershocks, but also magnitude 5s, magnitude 4s. There has been this movement going south out, southwest, and now boom, we get one going to the northeast, back in the direction of Alaska. So we have a lot of hot spots right now. This magnitude 7.3 rupture on the 16th of July. We had the 6.2 that followed up on the 21st. And then of course, I just reported yesterday on this magnitude 6.3 that ruptured here in the Malacca Sea. And that was at a depth of 144.6 kilometers. So another deep earthquake, though this most recent one is about double the depth. It's a little bit more than double the depth of that one. And that magnitude 6.3 was close by to magnitude 6.7 that we had July 14th, which kind of started this entire wave of seismic energy. But the real progenitor of that most likely is the sun, because we had this coronal hole high-speed stream impact. And in fact, with this most recent earthquake here, we did have a low density stream of solar wind below that threshold. So we were hovering in that 1 particle per cubic centimeter or less zone, a little bit of oscillation above it too, but nothing more than 2 particles per cubic centimeter. In general, anomalously weak, low density solar wind, which seems to pull these earthquakes out of the earth. You know, these faults are already clearly locked and loaded and ready to rupture, but it seems that sometimes they need a bit of a push. And that earthquake here, this double sequence of the 6.6 and also the 6.1 that just occurred in Kamchatka, there was also a magnitude 5.8 aftershock, I believe, that followed right after in this zone. That all coincided perfectly with the new moon. So that is very interesting. So that's what we're going to cover in today's video. Just a quick Earth geophysics and space weather update. Let's get right into it. Right from the get-go, I would like to give a shout out to Richard Cordaro, who is an earthquake researcher and physicist who tracks the impact of planetary alignments on earthquakes, and he tracks magnetic anomalies that are produced by these planetary configurations. So some very interesting work that he does. He was tracking this area here over the past 36, 48 hours. I was watching those updates on Twitter X. And that's because we had a sequence of planetary alignments and impacts in that zone. So when these angles go precise, you can track the location of that, and they all lined up right in this zone here, as you can see. So we had a 120-degree angle between the moon and Saturn, as well as Neptune, because again, Saturn and Neptune are nearly conjunct now. And they are in that alignment. So we see that 120-degree angle. Then we also see our new moon there with that moon-sun conjunction. And then because Pluto is opposite the sun right now, we also had a moon-Pluto opposition. Of course, there's also going to be a sun-Pluto opposition built into this. But a whole sequence of planetary resonances that he was tracking for this zone and basically saying, hey guys, we may have something big coming our way. And boom shakalaka, magnitude 6.6 and a deep earthquake too. And so I would just think in general that the influence of the planets on our Earth would be able to elicit some of these deeper earthquakes to come up. So we had that magnitude 6.3. That was about 150 kilometers in depth approximately. This is 314.2 kilometers in depth, and that impact zone is right in that area and less than 24 hours after this planetary resonances sequence. So shout out to Richard Cordaro. And we are still in that coronal hole high-speed stream impact, which triggered a G1 geomagnetic storm. Though geomagnetic volatility has now died down, the KEP index is around 3. The scale goes from 1 to 9. A 5 rating is a G1 storm. So we went up to a 5. Now we're kind of cooled off. We see these magnetic fluctuations across the globe here for the past 3 hours. And we see our legend there. So we don't see any of these really hot colors. Just maybe a little super tiny pulse of that. That's typical when you're in these sort of high-speed streams. You may get some fluctuations. It's never a 100% smooth ride. But if we look at our real-time solar wind, we'll see that solar wind density anomaly. So here we have our real-time solar wind as observed at the L1 Lagrange point. This is 1% of the distance from the Earth to the Sun. And so this gives us about a 1 hour heads up as to any sort of space weather headed our way. There's a variety of things that show on this portal. The link is in the video description to access this yourself if you want to check out this data, go back in time, whatever. We have our interplanetary magnetic field up top. The total field strength is the black line. We have our plasma density there, our plasma velocity, or the velocity of the solar wind, how fast it's moving through space, and also the temperature. This is our KP index, so we can track and correlate these things. Then we also see our phi angle there, and this allows us to see whether we've changed the orientation of the interplanetary magnetic field either towards or away from the sun. So we see that this coronal hole high-speed stream impact basically came in at the beginning of that. There's what's known as a co-rotating interaction region, or a CIR, a SEER. That's a very high density zone of plasma because the high-speed stream causes this plasma pileup. And so we see that our plasma density went up to about 10. Some values higher than 10, like 15 or so. But in general, we got out of this anomalously low, super low density solar wind, which was under 1 particle per cubic centimeter, went up to about 10 to 15. The solar wind strength got stronger, about 3 times stronger, but even up to like 4, nearly 5 times stronger at one point. That gave us that first jolt of geomagnetic activity, that G1 storm right there. We did get back to a G1 minus storm on the 23rd around noon universal time, and this is when the solar wind velocity started to increase. We see that go up here. We did peak out around 775 kilometers per second, and now we're firmly embedded in this high-speed stream. You'll notice our plasma density was getting lower and lower and lower. So we actually just had some of our lowest values here going down to 0.1. So this is right before that earthquake occurred, that magnitude 6.6, because that was at 2337. The magnitude 6.1 in Kamchatka was 2237 universal time. So we see that this is at about 19 to 2000 UTC. We also have a drop right there going very, very low at the density. And in general, none of these values are high. So, I mean, there's a value of 2, but we see it goes back down to below 1. And so it's just oscillating right now in between 0.1 and 2 particles per cubic centimeter. But as we've been discussing on the channel, one of the main things that occurs as a result of a coronal hole high-speed stream impact is that the solar wind density gets very low. And that seems to be the thing that's most correlated with these high magnitude earthquakes, because we have some really notable examples of there being low solar wind density with high magnitude earthquakes. Most notably, we can talk about the magnitude 9.1 Japan, March 11, 2011. That was right during a super low density high-speed stream impact. And then also the Sumatra quake, December 26 of 2004, magnitude 9. That also had anomalously low solar wind density. So the strongest earthquakes, at least of the 21st century, they did have anomalously low density solar wind in and around that time period when they ruptured. And we're seeing that happen right now with the 6.7 Banda Sea, 7.3 Alaska, 7.4 Kamchatka, 6.3 Molucca Sea, and now this 6.6 in between Fiji and Samoa, and also all the aftershocks in Kamchatka and Alaska. And about those aftershocks, here is that latest magnitude 6.1 that occurred in the Kamchatka swarm location. We see these seismic waves propagate out from the epicenter through the North American seismic network, first hitting Alaska. These colors there are for ground motion. So red is motion up, blue is motion down. So we're seeing the vertical displacement of the Earth itself as a result of that release of energy there at the Kamchatka Peninsula in Russia. So this energy wave spread out across the United States. Of course, it also went this way, hit Hawaii, went out towards Russia, went down to Japan, preferentially traveled along the faults, but we do see it just basically spreads out all over. And the really powerful earthquakes, they will also get picked up and pinged on the other side of the Earth. So this is just a visualization showing the scale of energy release from such a powerful geologic event. And these sort of earthquakes have been going off like crazy along the Pacific Plate, the Ring of Fire. All these earthquakes I've discussed have been happening in the Ring of Fire. So that whole area is just constantly loading other faults and critical stress zones with more and more energy. I also think it's really interesting that Hawaii, right in the smack dab center of the Pacific Plate, its last eruptive episode with Kilauea, the lava fountain like vent, you could call it, it did not like have this big lava fountain, but it had widened significantly. The overall volume of lava coming out was greater. And so Kilauea seems to be getting bigger and bigger with its eruptions. It has a fairly predictable schedule of about every 10 days at this moment in time. So we're just maybe about 6 days away. The last one was on the 20th of June. And so it'll be really interesting to see what happens in Hawaii around June 30th or so to see if it just gives us an amazing lava fountain show. Switching over to our 304 angstrom view of the sun, we'll notice that there have been some new plasma filaments that have launched off, though they are not Earth direct, but we'll see this first one there launch off. That is Earth direct, expected to come in on the 26th to the 27th. But you'll also notice some instabilities down there. There's the first one, and then right at the end, we get this second one to launch off. And so the sun has become a little bit more unstable as these new active regions have rotated in. Sunspots right now are at 120, and those solar flares have yet to break the M class threshold for quite a while now. They're starting to get closer and closer. The strongest solar flare today was a C8 flare. So we have a pretty active region rotating in. Let's switch to our 131 angstrom view. Here we have our 131 angstrom view, and I want you to focus in on this new sunspot group that's coming in right here. So you will notice some other activity there, some very bright but very brief flashes of light. And we just have a whole armada of sunspots that are rotating towards the Earth center meridian. But this one in particular is showing more activity than the others. It's just showing that kind of crackly electrical nature that is a sign that it's going to be a little bit more active than the others. So we will just have to wait and see what happens as it relates to solar flares. But sunspot numbers are slowly starting to go up. There's a lot of different groups on the sun, but there's not that many individual sunspots within each cluster. But if we get new flux to push out, that could change very quickly, and that sunspot number could rise up really quick to 150, 200, who knows. But this area right there is what I'm really watching. It's going to take about 6 days from where it is right now to get Earth center direct, but you can see that extra activity there and even some bright flashes from it just in the past 24 hours. And of course, happy new moon. Today it is the new moon. As we discussed earlier, we see that very nicely with our chronograph view here. There's where the moon is right now. So it's the new moon basically as I'm filming this video, and you'll notice this plasma filament that blasted off most recently. This is off to the west solar coordinate system. It's not going to interact with the Earth, but we do have that other impact coming up around the 27th. We'll check out that NOAA space weather model. But before we do that, you'll notice that we have a little friend here coming in to give the sun a kiss. Here we have a sun grazer comet, just a tiny little guy, but it is flying in, and it doesn't look like it's really made it, though it's difficult to tell at the end because of this plasma film kind of obscuring it, but it may have already vaporized. But that is flying into the sun at the same time. We have the new moon. The day out of time is tomorrow. There's a lot happening right now at this moment in time, and those magnitude 6.6 and 6.1 earthquakes are the most recent release of seismic energy on our planet, and I think that earthquake seismic wave is going to continue. And here we have our latest space weather model as provided by NOAA, and this is for that plasma filament which launched off. Actually, there's evidence that it was multiple things that kind of launched together. 3 different solar storms are really combining into one. And so we see that go out, Earth, center, and direct, basically moving right towards us at this moment in time. This is the top-down view, so we see that going and hitting us in terms of its angle. It's right towards Earth. And here we see our south-north, so it's right along that ecliptic plane. And this is when we get that bump in plasma density. This is not expected to be a big impact. That's going to come in around 8 a.m. Universal Time on the 27th. According to this model, the NASA model is faster. It's showing it come in like midday on the 26th. So we'll just have to wait and see. I don't think this is going to be the biggest impact, but there are some others thinking that it may be a little bit more bigger and stronger than expected. So I've seen some interesting forecasts out there for that, but I would say G1 is probably what's going to happen. G2 probably shouldn't be a surprise to us though. Anything beyond that from the plasma filament would be quite remarkable, but it really, again, it depends on the magnetic field configuration of that impact. And it is technically like 3 of these things kind of all launching together. There's a little bit of variability with that. But if it just happens to have a really nice, super strong negative southward component, the total field strength can go up quite a bit, we could all of a sudden be in some pretty powerful geomagnetic storming. So it really depends on that. That is hard to forecast because we're looking at the sun, we're looking at chronograph images, and then we're making a lot of determinations based off of that. But we don't have an advanced probe, let's say like halfway right now, that we can use for forecasting. We have just Discover 1% of the way. So we'll have about a 1 hour heads up. Once we start getting this data coming in on, let's say, the 26th or the 27th, we'll know, we'll have a better sense of what sort of geomagnetic storm we're going to have. But that's going to be another energy perturbation on top of everything that's already happening right now here on Earth. And before we're signing off, let's look at our global seismic activity level as provided by Volcano Discovery. Just for the past few days, we see this 6.7 Banda Sea, 7.3 Alaska, 7.4 Kamchatka with aftershocks. And then we see our most recent increase in seismicity with the 6.6 and 6.1 today. So we see this overall little seismic burst there. It's not the biggest one we've ever seen on the planet by far, but definitely notable. And the space weather conditions have been notable. So that is a fitting explanation for it. Of course, it's multifactorial. But I would encourage anyone that's interested in this to research into it more themselves. Now, we also have our Schumann resonances here, and we have been picking up some interesting energy in that pre-earthquake signal range, which is about 20 to 30 hertz, specifically mode 4 of the Schumann resonances, Earth's naturally resonant energy fields, at 25 hertz. So we see that increase in signal strength about 24.8 hertz right there. Also a little bit of chatter right there. If this goes further back to, I posted about this on my Twitter X, that's at Stefan Burns, G-O. And then we see it kind of died off, but we also do see this vertical spike right there. And so let's just, I haven't done this yet. Let's do this right now. We're doing it live. 23:37 Universal Time is the time for that 6.6. That is very deep. It's also under the ocean water. So any sort of signals emitted from that will typically get absorbed, but let's see what that looks like here on our data if we get any sort of connection there. This is UTC +7. This is observed in Tomsk, Russia, so very far away. But that would put that at 637 UTC +7. And here we don't see anything specifically at 637, but we do get that little activation just less than an hour before. Actually, it looks like exactly 1 hour before we get that bump right there. So that's interesting. And in general, we've just been seeing like these subtle activations of the Schumann resonances, like for example, right there and also right here. Just we've been seeing at times mode 1 resonating stronger than normal. And so there are natural variations to this, of course, and this is one of them, but this could be because of how the ionosphere is starting to slowly get more energy as a result of these solar flares. They are starting to pick up. We just had an electron precipitation event that would have charged up the ionosphere as well. We're still in solar maximum in general, and so the ionosphere is well charged, and that influences the Schumann resonances and the overall global electric circuit in many ways. So I will keep you up to date with what is happening on this channel by looking at all these factors and more. Again, I've been your host, Stefan Burns. Thank you all so much for watching, for your support. Wishing all of you well. Please smash that like button to help the channel grow and subscribe to stay in the know. That is my promise to you. When things happen, I am there. And so please take care of yourselves. Wishing all of you well. Happy new moon. And I will see you all tomorrow for a Cosmic Connection meditation live stream. Make sure you join in on that so we can resonate out that energy of peace and harmony, because that is the day to do that. So thank you so much, and I'll see you all in the next video.